This is a visual query system, or VQS, that we have developed within the Optique project. The goal is to enable end users to formulate queries with less skills and knowledge than would be required for a textual query language. A visual query system is a system of interactions between a user and a computer that generates textual formal queries through direct manipulation of visual representations of the domain vocabulary. Our VQS is built on widget-based user interface mashups. A user interface mashup aggregates different applications into a common graphical space and orchestrates them for common goals. Widgets are the building blocks of our UI mashups and refer to portable, self-contained, full-fledged and mostly client-side applications with limited functionality and complexity. Widgets in our system communicate with each other by delivering events generated by user actions to each other through a client-side communication channel. This approach gives us extensibility and flexibility. In our VQS, we initially have three widgets. The first widget is a menu-based query by navigation widget, which allows us to navigate concepts through pursuing relationships between them, and hence joining relations in a database. The second widget is a form-based widget, which presents the attributes of a selected concept for selection and projection operations. The third widget is a diagram-based widget, which provides an overview of the constructed query and allows users to revisit previously edited parts of the query. Let's formulate an example query with our visual query system. Given an ontology of the NPD fact pages domain, we would like to ask for all fields that contain an oil-producing facility and are operated by the Statoil company. In the output, we would like to see the name of the field, the name of the facility, and the remaining amount of oil in the field. The first thing the user has to do is select a start concept, which is field in our query task. It is possible to shift the focus later on, so this choice is not critical. The query by navigation widget lists all the available concepts at this point. Each concept is accompanied by an icon, a description, and a possible number of results if the concept gets selected. Let's use the search bar provided by the widget to find the field concept. Here it is. Let's click on it. As soon as we click on the concept, it appears on the diagram-based widget as a variable node. The selected concept becomes the active concept of the interface. As you see, the form-based widget became active and lists all the attributes of the field concept. Now let's add the name attribute of the field concept to the set of selected output variables. You see that there is an eye icon next to the name attribute, which is deactivated by default. By clicking on this icon, you can add this attribute to the output. Let's click on it. Now the name attribute appears within the field variable node with the letter O standing for output. We also need to add the remaining oil attribute to the output, as our query tasks demands. Let's do it by clicking on the eye icon next to it as well. Here the attribute is moved up by the system. This is to group selected output items together so that the user can easily find them later, in particular when concepts can have a large number of attributes. Remember that the query was supposed to find fields containing a certain type of facility. So the next step in our query could be to create a facility variable node and connect it with a field variable node. When we selected the field concept a minute ago, the content of the query by navigation widget changed. Now it lists all the concept relationship pairs pertaining to the field concept. We opted to aggregate the range and relationship into a single selection to minimize the number of interactions. Let's select the facility concept. The facility concept has now appeared on the diagram connected to the field variable node by a hasFacility relationship. Now from the form-based widget, which already shows the attributes of the facility concept, we need to constrain facilities to oil-producing ones. We do so by selecting the relevant option from the function attribute presented as a select list. As you see, the attribute appeared in the facility variable node in blue and with letter C standing for constrained. We also need to add the name attribute to the output. We simply click on the eye icon. Finally, we were interested only in fields operated by Statoil. For this, we also need to create a company variable node and connect it with the field variable node. We can easily jump back to the field concept by clicking on its variable node in the diagram. The focus of the interface changes to the field concept now. Let's click on the company concept. Here it appears on the diagram connected to field variable node by an operated by relationship. Take a look at the diagram. We have constructed a branch here which represents the logical AND connective. At this point we need to constrain the company name to Statoil. We will use the name attribute for this purpose. Now I do not remember the official name of the company, but let's try our luck. Here it is, Statoil Petroleum AS. After typing the first two letters, the autocomplete mechanism saved us. Finally, our query is complete. We can manipulate our query easily by clicking on any of the variable nodes. Now, what we need to do is to check the results. Let's run the query. And here we see the results of evaluating the query. As we see, there are 3 columns for the names of the fields, the names of the facilities, and the remaining oil in millions of cubic meters. Also, the system realizes that concepts like fields and facilities have a geospatial extension, and therefore it offers to show the results also on a map. If we click on this link here, we get the map visualization. Here we can zoom in, and then we can see the geospatial extent of the fields and the location of the facilities.